everyone and welcome. In this video, we present to you our game called the Doom Dungeons and show you the details of the game as well as the sections of the code itself and explain how it works. But first, let's watch a short video of level 1 playthrough. Doomed Dungeons is a two-dimensional game that is using a grid system to draw the game world. Our game scene is operating on ECS, which stands for Entities Component Systems. ECS allows us to assign components to entities in our game and move them around. Let's talk about the grid system. So our grid system consists of 20 by 12 tiles, and each tile is a 64 by 64 pixels. These tiles can be occupied by one or more entities, and there's four categories for our entities in this game. One is texture, which is the walls, doors, and the floor. NPC, which is the enemies that are in the game. And third is the items that we can pick up and use, or they will automatically be used. And number four is the player. So next we have the components to assign to each entity. I have a screenshot of our component class on the right, and I have some details on the left. As you can see, our C-transform component is assigned to the player, the NPC, the tile, and the item, because all of those need to have a position in our grid. The health component is only assigned to the player and the NPC because the tiles and items don't have health bar. The follow component, for example, is only assigned to NPCs, and the input component is only assigned to the player. Next, I would like to show you how each tile is assigned to its relative position to the game coordinates. Each tile is specified by its animation name, room number, tile number, and whether or not it blocks vision or movement. The first two integers are representing the room number, and the second two integers are representing the tile number in which that tile exists on. If you remember, tile 00 was on the top left and tile 2012 was on the bottom right, and this is what the room looks like after we load in each texture for each room. And for all the rooms in the game consists of 10 rooms per level. The player spawns in room 00 in the center, and the boss room is located in room number 02 on the bottom. And this is what the game looks like after we put in the 10 rooms next to each other. This is representing level 1. As you can see, we spawn in the middle and the boss room is on the bottom. Next, I would like to talk about the type of enemies that we have in the game. The first kind is Tekti, which travels in a given path. The second kind is a knight, which will follow the player and go toward it and does damage when they collide with the player. The third type is the small Octorok, which is used in the boss room. And the last type is the final boss, the Octorok, which we will talk about in details later on in this video. Here we see an example of enemy specification in our level file. To specify an enemy, we have given it the name and animation, as well as the room number and tile number, whether or not it blocks vision or movement. The next two integers are its health and its damage, and the next string is the type of behavior they're on. So it would be different if they were boss or they were a Tekti, which will be follow in that case. The next two integers are speed and the number of position they will patrol between. So in this case, we have number 4, which means there is 4 positions in that given room that this NPC will travel between. And these 4 points are given by the next 8 integers. Next, we have the item specification. Similarly to NPC, we have the type, the animation, room number, tile number, and in this case, they don't block vision or movement. And last, we have a player specification, the position, which is given by pixels in our world, and the bounding box in which the player collides with enemies or tiles in the game. The speed in which the player moves, its health, its regular attack animation, which is bullet in this case, number of bombs, and the amount of damage it does to its enemies. Our overworld map draws the position of the player on the corresponding level selected by the player. It also constructs a string showing the player if that level is locked or not, and it also draws a check mark next to completed levels. Our Rebind key program is implemented in the settings menu. The key values are stored in the game engine so we can use them everywhere throughout our game, and they are accessible from the menu as well as inside the game. I would like to mention that you cannot rebind your keys to the hotkeys that are already in place, such as C, M, P, T, or space. Now I would like to show you how rebinding works. The progress scene is shown when the player presses P in the game, and it shows the score, lives, and the difficulty of the level in which the player is playing it. It also indicates the status of the player in that level, showing if he has died, if he has finished the level successfully, or the game is still in progress. It also navigates the player to the menu after the level is completed or when the player runs out of lives. And it also returns to the game if the game is still in progress.